Good evening and welcome to my channel Physics Fun. Today we are going to learn about the satellite. Now, what is satellite? An object revolving around the greater mass is a satellite. And the classification of the satellite are natural satellite and artificial satellite. So what are the natural satellites? Name of the natural satellites are Moon, Titan, etc. Now here we are going to find the orbital velocity of the artificial satellite, its time period, etc. Now to find this, find orbital velocity, that is V0 of artificial satellite. Artificial satellite. Now to draw the path of the satellite. First draw the Earth of radius r, this OA, now at a height of small h. This is the orbit. When an artificial satellite revolving around the Earth, there should be the two forces. Number one is the centripetal force and another is the centrifugal force. Now to find the V0, we have to consider the two forces. Here this is the centripetal force. What is the value? Fc is equals to G into M into small m by r plus h whole square. Capital R is the radius of the Earth and small ih is the altitude of the artificial satellite from the Earth's surface. Now the centrifugal force here is m v0 square by r plus h. Okay. Now the satellite at that orbit is in the equilibrium condition. As it is in the equilibrium condition, we should consider that Fc is equals to m v0 square by r plus h. Now Fc is equals to G into capital M into small m by r plus h whole square is equals to m v0 square by r plus h. Now here we have m will be cancelled out and one rh should be reserved from this equation. We have the v0 square is equals to gm by r plus h. So v0 is equals to under root gm by r plus h, which is the orbital velocity of the satellite. Now replacing gm by r plus h by g dash, small g dash, we have g dash by g is equals to g dash by g is equals to r square by r plus h whole square. Okay. Now also we have the equation g dashed is equals to gm by r plus h whole square. Now replacing the gm is equals to r plus h whole square into g dashed. Now putting it in that equation, what will get? V0 is equals to under root r plus h into g dashed whole square by r plus h. What we have, that is equals to under root g dashed into r plus h. This is the expression for the orbital velocity of the artificial satellite. Now let's move to the geostationary satellite. What is geostationary satellite? From the word geostationary, geostationary. What is geo? Geo is the earth. And what is stationary? That's a station where the train stops. So from that word we get the concept that the which satellite is seems to be at the stationary position on its orbit from the Earth's surface. It is called the geostationary satellite. Now the geostationary satellite may be at the height of 720 kilometer, and it has its plane on the equatorial plane. It is lying on the equatorial plane, and its time period is 24 hours. That resembles to the time period of the Earth. Now we have the orbital velocity expression is V0 is equals to under root gm by r plus h. Now if the capital R is much greater than small h, that is the height of the altitude of the artificial satellite from the Earth's surface is between the 100 kilometer to 120 kilometer. So the orbital velocity expression becomes V0 is equals to root under gm by r. And what purposes the geostationary satellites are used for? Number one, for the transmissions of the waves, etc. So we have the expression of the orbital velocity of the artificial satellite, geostationary satellite, are also the artificial satellite. So the expression, from that expression we will find the time period of the artificial satellite. We have V0 is equals to under root gm by r plus h. So gm by r plus h. Now the time period t is equals to 2 pi into radius is r plus h by v0. So putting v0 we get 2 pi into r plus h by v0 is r plus h whole to the power half divided by root under gm. So we have 2 pi by under root gm into r plus h whole to the power 3 by 2, which is the expression of the time period for the artificial satellite. So for this lesson we have learned about the artificial satellite, its orbital velocity, and also the geostationary satellite and its uses, and the orbital velocity of the geostationary satellites, and the time period of the artificial satellites. So for the day, this is a complete package for the day. Learn it, clear it, and ask the questions in my inbox. Please share, subscribe, and like my videos. Okay, goodbye.